Hello, everyone. It's Dr. G. Hey, today what we're going to talk about in marketing research is the second part of analyzing the Titanic database. So we are going to look at the concept of correlation between variables. And today how we're going to do this is by using Python, Anaconda, using some script to be able to walk us through crunching the numbers so that we can analyze those statistics. So for those of you who have not yet installed, or you're not aware of how you install Python on your personal computer, I will leave an instruction link in the comments and you can always check with Canvas. So let's get started here. The first thing that we're going to do is you are going to open up in Canvas in module number 7, this worksheet here, which is correlation analysis on the Titanic data set using ticket class. So you'll notice here, everything that I have for you to complete in this assignment is going to be on one page. I understand it looks a little bit messy, but I want you to be able to have everything in one page so you don't have to keep flipping back and forth from the code you're going to create to the actual document you're going to do your analysis in. So the first thing you need to do is to create or make sure that you have Jupyter Notebook open. An easy way to do that, I am on a PC right now, or a Windows program. If you are on a Mac, you follow the Mac instructions. So what I'm going to do here is I'm just going to type in Jupyter. You'll notice that my Jupyter Notebook Anaconda pops right up on my search bar. So I'm just simply going to open that. Now right here, this is all the background dialogue, and that slips away into the background. If it doesn't, just minimize it so that it shows at the bottom of your screen. Okay, so you can see here all of the great files that I have working here. What I want you to do in this particular case is I want you to open, or I want you to create a new Python kernel. It's called right here. So go up and open that up. You'll notice here that it gives you an untitled name. So let's just click on that and then call it your first initial, last name. Then I usually put an underscore, Titanic. No, it's not letting me. Okay, correlation. Forgive me if I have a spelling error here. I'm not the best typist in the world when I'm trying to work on statistics here. So then once you do that, just rename it. So what you're going to see here is this is your notebook, and we are going to input our code to help us run the data right here within Anaconda. So I have for you that document again. Flip back to the document. So you've done step 1 here. You've opened the Jupyter Notebook. You've renamed it. Make sure you have correlation in that notebook name. And then the first thing what we have to do is we have to load in the libraries that are needed to run this analysis. So we are going to go into our Jupyter library. Actually, we're going into Panda. I want you to go in here and copy this input code, and you'll see what it's going to look like here. Go back into, mine is in the Microsoft button here. Go back into this code line here that says in. We're going to input by pasting that code right into Python here, and then select run. Now you'll notice that it pops up another input box. If there was something wrong with this code, you would get an error, and we would need to address that error. So that worked fine because it popped up a new code. Let's go back into our document here. The next thing we need to do is we need to input the data file. Now this is really important. Remember when you created your data file when we did the descriptive statistics? You need to find that file path wherever you have it saved on your computer, and you're going to copy that path and paste it here. Now, it has to be exactly as we have it here written. So in mine is, I created a temporary file. Mine is C:// make sure it's a / your directory / your name of your file .csv, and that is in the quotations here. So I have mine created there. You are going to have to input your particular file path. So I'm going to copy that code, go back into Python, paste it, and then again select run. Okay, so see, you can see it's reading here my code. It's popped out in red. So my file is being read by Python. Now, if you accidentally put in the wrong path or it couldn't find your file, you're going to get an error there. So you'll want to make sure to follow this code specifically with your path. Next, go back to the worksheet. Remember, we're just getting ready here. It's read the data. You've loaded in your libraries to do the calculation. So that's the most, that's how you're going to get started. Next, you're going to, in a step 2, we're ready for our analysis. So the first thing that we're going to do, similar to what we did when we looked at descriptive statistics within the Excel, and we looked at descriptive pivot tables for different variables, we are going to look at ticket class here. So what I want to look at are the variables P class. So if you were to go back and take out your code book, you can see that P class is passenger class. And then we want to look at the variable survived. Do you remember from the code book, survived is whether they lived or died. 0 is they survived. 1 is that they did not, hold on. 0 is dead. 1 is alive. Okay, so you're going to copy that code just like we did with loading in the data files. Go right back into your file, and we're going to input that code. Once we've input that code, run it, and voila, look at this. You now have a chart that's looking descriptively at this analysis. So you can see here we have first class, second class, and third class. So if you remember, the 0 are those people who did not make it, and the 1 are those people who survived. So you can take a glance at this right here and sort of look at, oh my, look at third class. Third class, there's an awful lot of people who did not make it compared to those who did. Here it's a little bit second class, and first class is a little bit more even. So you've got a good piece of analysis chart there for you. I'm going to copy that image. Then I want you to go back into your worksheet. This is so I know you've done the work, and you are going to paste it. Once you've pasted it, tell me about interpreting this information in your own words. Talk about first class versus third class. And the question is, does the initial count show a difference in survival rates between ticket classes? So I will let you interpret that information, type right in the box. So we've done the first piece of analysis. Now what I want to show you is that code that we used for counting, or sort of a descriptive look at the statistics. You can use that code and you can create whatever analysis between variables you are interested in. So next I have adult male and survived, because remember they said women and children off the ship first. Let's see how many adult males did not survive versus those who did. So I'm going to take that code, I'm going to copy it, go back into Anaconda, and I'm going to paste that. Run. and I have another chart here. So in this chart, you can see you have, did they die or did they live, based on adult male. So copy that image and then paste that into your workbook. You can clean it up here a little bit like I do to not waste so much space. And I want you to remember 0 is they did not live and 1 they did live. So now we're just looking at adult males. So I want you, from what you know about statistics, to interpret this chart. All right, we're done with the first 2 steps. Now we're going to do the fun stuff. We are going to look at correlation. So right now, what we were doing before was just counting descriptive statistics, similar to what you can do in Excel or any sort of survey program. So what I'm going to do here is I am going to look at a correlation matrix. And if you remember what correlation is, it's the relationship between 2 or more variables. It helps us better understand a strength of a relationship and whether or not it is significant for us to be able to do some further looking into that. So let's take a look. What I did here is I copied. The first thing we have to do is we have to tell the program here that we're going to run a correlation. So we're getting that correlation matrix. That's the code on how to do that. Now you're going to hit run, and now here recall that if you goes to another input, it went in properly. There were no errors. If there was something wrong with the code, it wasn't reading a correlation, or we had some sort of formula wrong here, it's going to get you an error, and we're going to have to revisit that. So that's just loading it all ready to go. Now what we're going to do is we are going to create a code to visualize the correlation matrix. So we're ready to look at this, and we do this through a heat map, and this is kind of fun. And we're going to copy and paste the code first, and then I'm going to show you how we, whoops, I didn't want to do that. I'm going to show you how we go ahead and interpret that. So paste that code. You can see right here, it's going to do a correlation matrix for us. And here you can see here that it's the minimum is 1, -1 to 1, which is what a correlation is. And then here we're going to do some coloring to see the heat map. Let's run that. And voila, look what we have here. We have a correlation matrix. This looks a lot different from your SPSS or your Excel that you're used to looking at. What this does, it gives you an interesting look at correlation in that it shows you, if you recall from a correlation, a perfect correlation is 1, whether it's positive or negative, and no correlation is 0. So when we think about a positive correlation, is that the 2 variables move in the same direction. If it is a negative correlation down here, they move in inverse relationship with one another. So let's look at this. So here we have the correlation matrix, and we're doing it by the red. The closer you get to red is the stronger the relationship that is positive. The closer you get to dark blue, the stronger the relationship is in a negative fashion or inverse. So let's take a look here at the matrix. So we have the variables here and the variables here. Each one of your variables from the database. And if you look here, we've got survived in the first column up at the top and survived here. So this is your matrix. So what the 1 is telling you is there should be a perfect correlation between a variable and itself. So each one of our variables throughout the correlation compared to itself will be 1. Now remember, the darker shading to red is a positive correlation. So here we've got, let's look here, we've got siblings and parents together. That is this variable. And over here we have purchase. I wish I could remember what that means. I think it's purchase fare or purchase class. So you can see that this has a 0.42 correlation, these two variables, meaning that it is a moderately positive correlation. Now you need to think about, remember, the closer to 1, the perfect correlation. So or the perfect relationship. So we're trying to look for the highest or the lowest, and we're just going to analyze these. So let's see what our worksheet is asking us to do. Once we go, oops, I keep making that mistake. I am going to copy that image and paste it into my document. So I have it right there, so I don't have to flip back and forth between my questions. So you're going to paste your correlation map into the worksheet. Now let's review the matrix for a couple of things. We were looking at passenger class. So let's look at passenger class and fare. So the fare is the amount they spent on their ticket. So you would imagine that the higher the dollar amount of a ticket would be the higher the class, right? First class, second class, third class. So think of the plane. Those people in the front of the plane probably paid more than the people in the back of the plane, depending on your airline, of course. So let's take a look at passenger class over here. And then we're going to scooch over to the fare column. And you can see here that we have a moderate meaning it's halfway to 1 or -1. In this case, we have a negative correlation of 0.55. So remember, our data indicates that with a negative correlation, there is an inverse relationship between the two variables. So passenger class, if you recall, passenger class is 1 is first class, 2 is second class, 3 is third class. So if you look at passenger class and fare, it makes sense because the lower the passenger class, or the higher the passenger class, is inversely related to the fare itself. So if you're in third class, because that's the highest number, your fare is going to go down. If we were looking at first class, and so that's what the data is telling us, is that the higher the class, the lower the fare. So that is what a negative inverse relationship is. So you're going to type in that negative, what was it, 0.55 here. Now I want to describe what that means, just as I interpreted it for you. Okay, the next one we're going to look at is, what is the correlation coefficient between adult males and traveling alone? Well, this is interesting because when was this? 1912, 1918? I don't remember the exact year. But if you imagine going on a ship across the Atlantic, and you know, it's kind of a scary thing. Perhaps, you know, there's lots of reasons why males would or wouldn't travel alone at that time in history. So let's look at this. Let's look at adult male here in this column. And then we need to figure out whether they're alone or not over here. So we've got a positive correlation between males and whether they traveled alone or not. And it is a relatively moderate 0.41, not quite halfway to 1. But you can see here that the positive relationship between adult male and alone is positive. So that would mean that if they're alone, they would likely, if they were an adult male, they would likely be traveling alone. There's some sort of correlation there. We'd have to dig a little bit further, but we're just looking for a relationship. The relationship is positive, and it is moderately strong. Okay, so then I want you to list 2 other variable sets here that you're interested in. Maybe you're interested in age and whether they survived or not. Maybe you're interested in age and class. So take 2 different variable sets. Tell me what the Pearson correlation coefficient is. So it may have seemed like a lot of work to get to that point, but trust me, when you're working with data that is not a full set and there's a lot of nulls in there, if you recall from Excel, you cannot run correlation or regression or even descriptive statistics in the data analyzer without cleaning the data. Our code helped us clean this data, and we were able to run the analysis lickety split. So that's correlation. And what I'm going to need you to do is to please, for the final assignment that we're doing with the Titanic, you're going to upload all 3 worksheets at one time so I can see your final work. So take care, everybody, and happy number crunching.